Okay. All right. So as long as the highest exponent is 2, we're fine here. Okay? Where's my draw function here? And you see the highest exponent right here is 2. My question here is, here's a linear equation. Here's also a linear equation. Here's another linear equation. Here's another linear equation. Oops, 10. What is the highest exponent in these ones? What's the highest exponent in these equations? And remember, if I have an exponent, if I had this, what was the answer for this? X times x4. What did that equal when we're looking at exponent law? Can anyone tell me the answer for this question? X times x to the power of 4. What's my answer there?
X to the power of 5. Sorry, I don't
Good.
have access to the chat.
Oh, that's no problem. So what exponent is on top of this x?
A 1.
A 1. Good. So what exponent's on top of all these ones? A 1. Therefore, for a linear equation, okay, is a 1. Does that make sense to everybody? Oh, I'm dying on the vine here, people. Give me a Y in chat or a yes in chat if that makes sense. Okay. And the reason it's a quadratic, Dominic, you asked earlier, is quad refers to a 2 as an exponent. Okay, so that's why it's quadratic. So any equation that has x to the power of 2, right, is a quadratic. Now I can get tricky and go like this. And that's still x to the power of 2 because when you FOIL that, you're going to get x squared there. Okay. Now let's go back here. Since we kind of know what we're looking for now, what's common between these two? What stands out in the equation when you look at the rest of these? What's different about these two compared to the rest of them? What tells you that it's a exponential equation by looking at the equation? I'll go back here and I'll write a whole bunch of exponential equations for you. Let's underline this green. I'm going to write y equals, for this, let's go y equals 2 bracket 3 to the 15. Oops, not 3 to 15. 3 to this. That's an exponential equation. This is exponential decay. Okay. What is common with these equations, the green equations, that are not in the previous equations? Okay, keep going with that, Dominic. They share the x. All the exponential equations are variable by the exponents. All right, so I'm going to put that in English. I think you have it, Farley. The exponent, the variable is an exponent. Very good in these questions. Okay. So if you look here, the exponent is the variable, where the variable, the letter here is always just a multiply or part of the equation. For this one here, it's the exponent. Yeah, I figured that's what you said. So you guys can fill in your notes to self right now. Here, so what makes an equation linear? What makes the equation quadratic? What makes an equation exponential? And I'd even write in a little, like a couple examples of it. Does that make sense, everybody? I'll come back here. So there's your definition for like, or you don't have to write the exact words I write. Write what makes sense to you. And then I write down 1 or 2 examples of it, so you get a good understanding.
Do we put that in equations?
Yeah, just
Okay.
beside the same spot you drew the little graphs, right? But just beside the semicolon there. That's where you're going to write the definition for each one. And then maybe write an example somewhere. All right, put a D in chat when you're all done for me, so I can get a general understanding when people are done. Okay, the last part we're going to do is we're going to do first and second differences. Okay. So the way you've done differences before, we did in grade 9 for sure. Okay. The way you do differences is generally you take the bottom number and minus off the top number. So -4 minus -7 would equal 3. Does that make sense? -1 minus -4 equals 3. 2 minus -1 equals 3. 5 minus 2 equals 3. So that's how you find differences. The first time you do the calculation is called the first difference. Okay. So what do you notice about all these first differences? What do you guys notice about all those first differences?
They all go up by 3.
Good, they're all the same. Perfect. So So first difference is I go up by the same amount. From a linear graph. Okay. So if you take your differences, if you take the first difference and they all come out the exact same, you're going to get a linear graph. Now if I go back to Desmos real here quick, I'm going to make a quick little, graph here. 0, 1, 2, 3, 4. Now if I go up by the same amount, so if I make this like 1, then a 4, then a, going up by 3, right? 7, then 11, 10, 13, 16. If you look here, that's going to make a straight line. And if I took the difference 4 minus 1, 3, 7 minus 4, 3, 10, 3, 3, 3. Okay? So does that make sense to everybody? Put a yes in chat if you understand. If I do the first differences and they're all equal, then it's a linear graph.
So that's how you tell the type of graph in a situation like this.
Yeah, if I just have a table of values, right? And I ask you, okay, what type of graph will this table of values make?
So since it goes up consistently, it's linear.
Correct. There's a pattern there.
Okay, I see.
Yeah. And when you take, like, if I made a second one right here, oops. X, Y, or whatever it is, not to be X, Y. 1, 2, 3. If it was like 10, 50, 90, 130, I could look here and go, okay, difference between those two, 40, 40, 40. Therefore, it's linear. Okay? So now, let's do another one. Let's take a look at this one, and we'll do our first differences. So 4 minus 1 is 3. This here is 5. This here is 7. This here is 9. Okay? Are all those equal, yes or no? Are all these equal? No. So we know it's not linear. All right, this is our first difference. Okay? So linear is not. So we're going to do a second differences now. 5 minus 3 is 2. 7 minus 5 is 2. 9 minus 7 is 2. Our second differences here are all equal. Okay? What does that tells us? It is quadratic. Okay? So if the second differences are equal, then the graph is quadratic. Okay? Let me do one real quick one here, and I'll graph it. So if I did -1, not -1, -3, -2, -1, 0, 1, 2, 3. If I did 9, 4, 1, 0, 1, 4, 9. If you look here, difference in this is -5, -3, -1, 1, 3, 5. Those aren't equal. So if I do the second differences, that's going to be 2, 2, 2, 2, 2. So we agree that the second difference is here. Here's my first difference. My second differences are all equal. If I go to graph this, here's my graph here. -1, sorry, -3, -2, -1, 0, 1, 2, 3. Get rid of these guys. I have to go 9, 4, 1, 0, 1. If you look there, it's making a quadratic. How do we feel about that? Yes, no, maybe so. Do we understand that? Amazing. Easy, Farley. Don't get too crazy. Now our last one looks like this. Let's do our first differences again. So that is 2 minus 1, -1, -2, -4, -8, -16. Those don't have negative signs on it. Those just should be positive signs. Let's redo this. 1, 2, 4, 8, 16, 32. First differences, are they equal? Yes or no? No. So let's try second differences. Oh, Kovats, you're alive. First time I saw you today. Second differences, are they equal? Yes or no? Is our second differences equal? Come on, people. No. Okay. So we know it's not a linear. We know it's not quadratic. We know it's exponential because that's the only other option I've given you. But what do you see about the numbers there that jump out? Does anyone see a pattern or something like that jumps out with the differences? You can look at the first difference or second differences. Very good. It's doubling. In this case, they're doubling. But there's going to be a pattern one way or another that's going to occur. -2, -1, -0.5, -0.25. So not the same. First differences, right? So let's do second differences. This will be 1. This will be 0.5. This is 0.25. Is there a pattern with that one as well? You see? So first differences are the same, second differences are the same, but is there a pattern with those guys? What is it? What's the pattern, Farley? They half every time. Okay. Good. Exponential table of values will have a pattern of growth, of increase or decrease in okay. Does that make sense to everybody?
Are these notes on OneNote like as you're doing them, or do you put them in when class is done?
No, these go automatically in the OneNote pretty much as I type it.
Okay.
It'll be in your content library, Tuesday class notes. So this part here, this is what we just did here. Rates of change for linear, quadratic, and exponential. When you do this, you could write like the definition in words, or you could accompany it by like a little table of values here showing it as well. But this part here is what we just did. Okay? For your homework, for practice is pretty easy. For your practice here, you will figure out the first difference. Tell me, like for this one here, I would say, okay, what's my first difference? Okay, that's going to be 2, 2, 2, 2, and so on. And how I get that, that is -4 minus -6. So I know it's linear. And I say how I know. Well, the first differences are the same. Okay? Then I do the same for this one. This one has second differences, and I go from there. Same thing, this one here is you're looking at the equations. Which ones of these are linear, which ones are exponential, same thing. Then do your graphing here too. What looks like what. Any questions on the homework part?
No, but can you go back to like the examples for rates of change for the graphs?
Yeah, I mean my note part.
Yeah.
Yeah.
Awesome.
It's so big you probably can't get it all. There's everything. If I fit it in one page. Okay.
So is it quadratic that has the second difference?
Quadratic is the second difference, yeah.
Okay.
Okay. So let's say 1 p.m. we'll meet back. Okay. At 1 p.m. make sure you have your what? Have paper in front of you, whiteboard. We're going to be doing a lot of question and answer stuff for the factoring part.
Mr. O,
Yeah, Yosan?
so do we write those into the notes itself?
Yeah, you can put those in your notes itself.
Okay.
That will go into the 3 parts right here, 1, 2, and 3. Rates of change for linear, rates of change for quadratic, rates of change for exponential. And you can make a table of values chart if you want, or you can just write in the definition, whatever makes sure that you will remember it.
Okay, thank you.
Okay.